use the definition to find the Maclaurin series for the following function: 4 times 1 minus x raised to negative 2. So the Maclaurin series is for a function that is nth derivative at 0 over n factorial x raised to n. So we need to determine these cn's. They are also called cn's. So let me do a table, because we need to find c naught, because this is from 0 through infinity. So first coefficient is c naught, c1, c2, c3, c4, etc. Then from those couple of constants we might see a pattern. So we write the closed form of this series. Closed form means using sigma notation. So let me make a table. Not needed, but it helps us to organize things. Okay, this is n. Now I want to find nth derivative of the function, then evaluate nth derivative at center, because Maclaurin means 0. Then based on this we divide by n factorial and we get cn. So n0 means the function itself, nth derivative, 0th derivative means the function itself. That is just 4 1 minus x raised to negative 2. Evaluate at 0 means replace x by 0. 1 minus 0 is 1. 1 raised to a number means this negative 2 is on the bottom, by the way. But 1 raised to square is 1, it's just 4. And c0 is this number divided by 0 factorial. 0 factorial is 1, so this is just 4. So n equals 1 means first derivative. Let's find the derivative of 4 1 minus x raised to negative 2. Derivative is 4 negative 2 times 4 negative 8, 1 minus x, negative 2 minus 1 negative 3, times derivative of inside 0 minus 1 negative 1. This negative negative is positive, so it's going to be 8 1 minus x raised to negative 3. Evaluate at 0, plug in 0 for x. 1 raised to number means 1, so this is 8. And c1, when n equals 1 means c1 is 8 divided by 1 factorial, just 8. Now n equals 2. Take the derivative, so it comes out to be 24 1 minus x raised to negative 4. Plug in 0, it is just 24. Now we are in level 2, c2. c2 means that divided by 2 factorial. Okay, so 2 factorial. So I'm going to write 24 divided by 2 factorial, that's 24 over 2, that's 12. Now 3, take the derivative, so 96 1 minus x raised to negative 5. Plug in 0, so we to f3, third derivative of 0 means this 96. Now we get c3, so 96 divided by 3 factorial. Okay, 3 factorial is 3 times 2 6. I divide, okay, 16. Maybe we have the pattern 4 8 12 16. Okay, can you see the pattern? Maybe let's find one more and we will talk. This one is, okay, I don't even multiply. It's 96 times 5, 1 minus x raised to negative 6. Plug in 0, that is 96 times 5. Okay, now we divide by 4 means 4 factorial. So 96 times 5 over 4 factorial, that is 4 times 3 times 2 times 1. Okay, and we simplify. Okay, so 4 times 3 12 times 2 24, 4, so 20. Now we see the pattern. Okay, this is 4 8 12 16, 20. So these are multiples of 4. So this is 4 times 1, 4 times 2, 4 times 3, 4 times 4. This is 4 times 5. So we can write in general, so Cn is starting 0, right? So n from 0, 1, 2, etc. So 4 multiples of 4. So when we take 0, we have to get 4. So we can think 4 times 1, 4 times 2, 4 times 3. So 0 means 4 times 1, 1 means 2. So 4 times n plus 1. Let's check. This is 4 times 4. Our n is 3. This is 4. Okay, this is n. This is n plus 1. We can think 20 is 4 times 5. So n is 4. This is 4 plus 1. So 4n plus 1 captures everything. We don't have to find everything now. 4n plus 1. Now we are done. Okay. Thus, the Maclaurin series is n from 0 through infinity. That's Cn. We found 4n plus 1 xn. Now we can find the radius of convergence, because whenever we deal with power series, then it makes sense inside certain intervals. So for radius of convergence, using an application of ratio test, so it will be, in this case we have Cn. There is no negative 1 to the n, all positive, so we don't have to even write absolute value. So Cn over Cn plus 1. Okay, this is kind of reciprocal of the ratio test. Limit n going to infinity of Cn. This is Cn 4 n plus 1. Cn plus 1 means 4 is 4, n plus 1 plus 1, n plus 2, 4 cancel, n plus 1, n plus 2. When n goes to infinity, they are same. So radius of convergence is 1.